Hi everyone, I'm Yimeng. The topic of my presentation is acid mine drainage remediation options in comb easeways. There are three parts in my presentation, including background, purpose, and methodology. For the background, what we need to do is to know the location of our research set. As we can see in the picture, the comb easeways mines lie on the eastern of Sierra region within the Eastways Valley. There are mainly three mineral lodes, and it has a long history of mining. As a result, acid mine drainage became a major environmental problem in this area, and the river Eastways is also polluted by it. So, what's the main pollution in this area? This picture shows that the concentration of heavy metal is really high. If you compare the eastways upstream and downstream, it has a big difference. Besides, this picture lists two main pollution sources on this site, namely Pierce Edit and Juice Lower Edit. Because the data shown was collected in 2016, we are not sure about the recent water quality, and there's still no relevant effective remediations applied to this area. That's what we need to do in this research, which is also the purpose. So, the purpose of this research is to find an effective method to solve the heavy metal contaminations in the water. And my hypothesis is that nanoparticles is useful to remove heavy metals in the water, and the efficiency will increase with higher pH. Because the pollution has existed for a long time, what we can do is to minimize the impact the polluting has on receiving rivers. It is important to choose a suitable method. As we can see in this picture, all the methods could be divided into abiotic and biological, and they could be classified as active and passive. The common active methods are using alkaline material such as calcium hydroxide or limestone to neutralize acid mine waters, and the metals can be removed as metal hydroxide precipitates and sulfate as gypsum slag. And the passive is to use natural or constructed wetland ecosystems. A permeable reactive bacteria is is one of the most commonly used passive treatment options, which make use of either chemical or biological process. The passive treatment option is more appropriate for application at abandoned mines than the continuous flow of acid mine drainage water, as, as it has benefits of low operational costs and maintenance. This is what I read from an article. So, the choice of passive treatment to remediate acid mine drainage is depend on the capacity of particular system of producing alkalinity and its efficiency of metal removal. Now we can see a table listing several common methods of removing heavy metals in the water, and their advantages and disadvantages could also be seen in it. It reminds me that when I choose a method, I need to consider the cost, the consumption of chemical materials, and waste disposal. So that's the reason why I choose nanoparticles. The common advantages we can see in these slides are fast and effective, and I prefer to choose magnetic nanoparticles because they could be recycled easily. No matter which method we choose, there are several steps that we must do. The first is sample collection. We need to collect 10 to 15 filtered water samples and 10 to 15 unfiltered water samples to make comparison. Besides, we also need to analyze the pH, the redox state, electrical conductivity, and the concentration of dissolved metals. I want to say that there are two types of techniques to measure the concentration of dissolved metals. I prefer to choose ICP-ES because the cost is lower and we don't need too much conscious concentrations of heavy metal. At last, I want to say that I think the magnetic nanoparticle is a reasonable approach to solve SMA drainage problems. These are the references, and is there any questions about my presentation? Thank you.